Alright, so here's a video for the review sheet we gave you today. This is homework number 49. I'm only going to do the back side, the 1 through 20, solve by quadratic formula, solve by factoring, and I'll throw in a few solve by algebra problems for you as well. So we're going to start with the solve by quadratic formula. On the test tomorrow, when it says use quadratic formula, if you don't use it, you will get marked off. You need to follow directions. Even if you can factor it, we still want to see if you know how to use a quadratic formula for that type of problem. So number 1 here, we have already equal to 0, so I can identify my A equals 1, my B is -2, and my C is -1. We plug it into my quadratic formula, which is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So I get -b, that's -2, plus or minus the square root of -2 squared, minus 4 times 1 times -1 over 2 times 1. So that's 2 plus or minus the square root of -2 squared is 4. -4 times -1 is plus 4 divided by 2, which is this way, so I have some room. 2 plus or minus square root of 8 over 2. Square root of 8 simplifies, it's 4 and 2, so I get 2 radical 2 plus or minus 2 radical 2 over 2, and I can divide all of the numbers in front here. These all can be divided by 2. So we get 1 plus or minus the square root of 2 divided by 1. I don't really need to put the divided by 1 there, and that's my final answer. Number 2, I need to get it equal to 0, so I'm going to add 5, and I get 2x squared plus 3x plus 1 equals 0. And we get A equals 2, B equals 3, and C equals 1. So -b, -3, plus or minus the square root of b squared minus 4 times A, which is 2, times C, which is 1, divided by 2 times A, which is 2. And that's -3 plus or minus the square root of 9 minus 8 over 4, which is -3 plus or minus the square root of 1 over 4, which is -3 plus or minus 1 over 4. And we're going to do that. We get -3 minus 1 is -4 over 4, which equals -1. And we get -3 plus 1, which is -2 over 1, which is, -2 over 4, which is -1/2. And those are my two answers, -1 and -1/2. Number 3. It's already equal to 0. We have 3x squared plus, I'm going to fill in this. This is 0x plus 8. You don't have to fill that in, but you need to recognize that because there's no bx term, the b is 0. So it's a equals 3, b equals 0, and c equals 8. So I get 0 plus or minus the square root of 0 squared minus 4 times 3 times 8 divided by 2 times 3. So I get plus or minus, I can put the 0 there if I want, but it's really unnecessary. I get -4 times 3, which is -12, times 8, which is 96. So square root of -96 over 6. And 96 is 16 times 6. Let's see. 36, yeah, 96. So we have 16 and 6. So the square root of 16 is 4. It's negative, so it's 4i, plus or minus 4i radical 6 over 6. And I have a common factor here. The 4 and the 6 can both be divided by 2. So I'm going to do that and simplify plus or minus 2i radical 6 over 3. And that's my final answer. Remember that I'm only dividing the number outside the radical by what's underneath and simplifying that. I don't simplify the number that's inside the radical. Okay, so now I had to make room for 4, 5, and 6. Number 4. Again, I need to add 16 so that I have it equal to 0. So I have x squared plus 8x plus 16 equals 0. Hopefully you recognize that that could be factored, but we asked you to solve it using quadratic formula, so we want you to do it that way. A equals 1, B is 8, C is 16. So I get negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 16 divided by 2 times 1, which is negative 8 plus or minus the square root of 64 minus 64 divided by 2. And that's negative 8 plus or minus the square root of 0 divided by 2, which is just negative 8 divided by 2, because when you add 0, you get negative 8, and when you subtract 0, you get negative 8. So x is negative 4. Number 5, 3x squared minus 2x. It's already equal to 0. So we have a plus 0 on the end, so that means our c is 0. So a is 3, b is negative 2, c is 0. And we have negative 2. Don't forget, if it's negative, you're going to have both negatives. Plus or minus the square root of negative 2. Oops. I don't know what I did there. Negative 2 squared minus 4 times 3 times 0 divided by 2 times 3. So that's positive 2 plus or minus the square root of 4, because 4 times 3 times 0 is 0, so I don't need to subtract 0 from that, divided by 6, which is 2 plus or minus 2 divided by 6. I get 4 over 6 when I add 2 plus 2 divided by 6, which reduces to 2/3. That's one answer. And 2 minus 2 is 0 divided by 6, which is 0. We get 2/3 and 0. And lastly, number 6. Subtract your 11, so x squared plus 2x minus 11 equals 0. Your a is 1, your b is 2, and your c is negative 11. So we have negative 2 plus or minus the square root of 2 squared minus 4 times 1, which is a, times negative 11, which is c, divided by 2 times 1. We have negative 2 plus or minus the square root of 4 minus plus 44 divided by 2, which is, we'll come up here, negative 2 plus or minus the square root of 48 over 2. 48 is 16 and 3. If you do 6 and 8, that's fine, but you have to break the 8 down some more. And then you can break down what's left. But I like to look at that as 16 times 3. It makes my life easier because the square root of 16 is 4. So I get 4 square root of 3, negative 2 plus or minus that, divided by 2. And I have common factor between 2, 4, and 2, so I can divide those. So we get negative 1 plus or minus 2 radical 3. And that's my final answer. And it would just be divided by 1. All right. Okay, the next set of problems solve by factoring. So I have 7q squared minus 12q equals 0. This is a binomial. There's no constant term. So what we're looking for is the greatest common factor. They both have a q, and that's the only factor they have in common. So I'm going to factor out the q, and q times q is q squared, and q times negative 12 gives me the negative 12q. And so I set each equal to 0. Q equals 0, and q minus 12 equals 0. Now, a lot of people left this part off on the quiz, so pay attention. When you factor out that q, it gives you an answer of 0, and then add your 12, so q equals 12. We get 12 and 0. Number 8, x squared minus 7x plus 6 equals 0. You're looking for two numbers that multiply, because I have a coefficient of 1 to 6, and add to negative 7. And when we do that, we get -1 and -6. -1 plus -6 is -7. -1 times -6 equals 6, +6. So my x is equal +1 and +6. Number 9, 6x squared plus 7x minus 5 equals 0. First thing I should do when I have a coefficient is look to see if I can divide them all by the greatest common factor to make it easier. In this case, I can't, so I want to look at 6. There's two options for 6x. There's 6x and x, and there's 3x and 2x. So we'll see which ones work for us here. Now the only way to get 5 is 5 times 1, so that's going to make that part easy. I can see pretty clearly if I put a 5 here and a 1 here, that's going to give me my outside. I'm checking my outside with my inside. That would be 30 and 1. That's not going to work. So let's try 5 and 1. My outside is 6, my inside is 5, that's 11 if I add, it's 1 if I subtract, so again, that doesn't work. So that means this one is not the correct factorization. Let's try the next one. If I put a 5 here and a 1 there, my outside is 3 and my inside is 10. Well, 3 and 10 will give me 3x and 10x will give me 7 if I subtract the 3. So that means the 1 here is going to be negative and the 5 will be positive. Then I set them equal to 0. 3x plus 5 equals 0. If there's a coefficient on this x here, the answer is not -5. You have to solve that equation. Minus 5, 3x equals -5. Divide by 3, and x is -5/3. And 2x minus 1 equals 0. Add 1. 2x equals 1. X equals 1/2. So our answers are 1/2 and -5/3. I'm going to pause it and clear it out here. Well, never mind. We'll just... Okay. Now let's make some room for 10 and 11. Number 10 is n squared minus 49 equals 0. We should recognize that immediately as a difference of squares. The n squared minus a perfect square. So that factors to n plus 7 and n minus 7. The pattern's the same if there's a coefficient that has that is a perfect square as well. So n equals -7 and +7. If it said, say, 81 n squared minus 49, this is a perfect square, the 81, the 49 is a perfect square, so it becomes 9n plus 7 and 9n minus 7, and then you can set them equal to 0 and solve. You get -7/9 and +7/9. This is just a little extra in there. And lastly, number 11, 6p plus 4p equals 0. Something tells me that that's supposed to have a square on it. So let's add it, because otherwise it doesn't really help us practice for the test. So I have a 6p squared plus 4p equals 0. I'm going to factor out a 2 and a p. Okay, a 2 and a p because it's a binomial with no constant term. So 2p times 3p gives me 6p squared, and 2p times 2 gives me 4p. And so if 2p equals 0, then p equals 0. And if 3p plus 2 equals 0, then 3p equals -2. Subtract 2, divide by 3, and p is -2/3. So we get -2/3 and 0. Unless it's a perfect square, you should be getting 2 answers. All right, completing the square. Number 12. The first step we looked at was, is it a perfect square? 20 is not a perfect square. 1 is a perfect square, so that means it's not. So we're going to move to the next step. Does it have a coefficient of 1? Yes. If it doesn't, then we divide by that coefficient. So it's just x squared minus 8x. And I'm going to move the 20 to the other side by subtracting 20. So plus something equals negative 20 plus our something. Remembering whatever we do when we get what completes the square, we have to add it to both sides. And we get that by b divided by 2 squared. Our b is negative 8, so negative 8 divided by 2 squared equals negative 4 squared, which is positive 16. So we're going to add 16 to both sides. Then we get x squared minus 8x plus 16 equals negative 4. And we can factor this because we just made it a perfect square. Remember, if you get stuck like it's a fraction, this number is how it factors, x minus 4 squared, because negative 4 times negative 4 is positive 16, and negative 4 plus negative 4 is negative 8, equals negative 4. Then we'll use the square root property to solve it. Don't forget your plus or minus. X minus 4 equals plus or minus 2i. And add 4, and we add it in front of the plus or minus, so it's x equals 4 plus or minus 2i. Okay, number 13, 3x squared plus 6x plus 24 equals 0. First, we want to know if it's a perfect square. 30 is not a perfect square, and 24 is not a perfect square, so the answer is no. We have to make sure that the coefficient equals 1, so we're going to divide by, oops, I didn't do that one, divide by 3. And when we do that, we get x squared plus 2x plus 8 equals 0. I'm going to move the 8 to the other side. Plus something equals negative 8 plus something. So we get b divided by 2 squared, that's 2. I keep getting that. 2 divided by 2 squared is 1 squared, which is 1, so I'm going to add 1 to both sides. Then I get this factors to x plus 1 squared equals negative 7. And we're going to square root both sides using our square root property. Again, don't forget your plus and minus. X plus 1 equals plus or minus I square root 7. Can't take the square root of 7, but I can bring the I out. And then subtract 1. X equals negative 1 plus or minus I square root 7 is our final answer. All right, and the last problem here. X squared minus x minus 5 equals 0. It's not a perfect square. Coefficient's already 1, so I can start by moving the 5. So we have x squared minus x plus something equals 5 plus something. And we take our middle term, negative 1, divided by 2, and square it. So negative 1/2 squared is positive 1/4. And that's what I'm going to add to both sides. And remember, we said our trick is that this number is what goes into our factor. So it becomes x minus 1/2 squared equals 5 1/4, which is 21/4 when you make it improper. And then we'll take our square root. Don't make it a decimal, because you don't know how to take the square root of a decimal without a calculator. So leave it as a fraction. Square root of 21/4. And we get x minus 1/2 equals plus or minus the square root of 21 divided by 2. And then we're going to add 1/2. And we get x equals 1/2 plus or minus square root of 21 over 2. Or you can write it as one fraction, 1 plus or minus the square root of 21, all divided by 2. Either answer is correct. And I can't simplify 21 because it's 7 and 3. Those are both prime. So that's simplified. Okay, so the last set of problems deals with performing the operations on the imaginary numbers. So when we're asked to multiply, like a number 15, we FOIL. Or we can use the vertical multiplication. So if you haven't seen that before, maybe you're in another teacher's class, when you learned to multiply as a kid and you had to do 15 times 35, you stacked them. Oh, it keeps moving on me. And so I'm going to stack them. And it works just the same. I'm going to multiply my 2i times my negative 3i gives me negative 6i squared. 2i times 7 gives me 14i. 4 times negative 3i gives me negative 12i. And 4 times 4 gives me 28. And I add it all up. 28 plus 2i minus, well, this is negative 1. Remember that I squared equals negative 1. So this becomes positive 6. And 28 plus 6 is 34 plus 2i. And that's my final answer. All right, number 16, 5 plus 2i plus 3 plus 2i. You really got to pay attention on these problems because I see kids just ignore the sign between the two parentheses, which means you're adding them. You're not going to FOIL this problem. You get 5 plus 3 is 8, and 2i plus 2i is 4i. And that's your final answer. Number 17 is 7 plus 2i minus 3 plus 2i plus 4 times 2 minus 6i. So I'm going to distribute this 4 first. And I like to distribute the negative, just to remind myself. So I get 7 plus 2i minus 3 minus 2i plus 8 minus 24i. Now I'm going to add up all my real numbers. And I get 7 minus 3 is 4, plus 8 is 12. And I'll add up my imaginary numbers. 2i minus 2i is 0. Minus 24i is minus 24i. So my final answer is 12 minus 24i. Number 18, negative 8i times 2 minus I. I need to distribute. I get negative 16i plus 8i squared. And again, I squared equals negative 1. So that becomes negative 8. 8 times negative 1. Negative 16i minus 8, or negative 8 minus 16i. Technically, it should be written with the real number first. Number 19 is 3 minus 6i squared. Move some of this stuff up so I have space. Let's delete this. I'm just going to delete it. Make space for me. Let's try that again. 3 minus 6i squared. We want to think that we can do square the first and square the second, but we have to remember that when we square binomial or any number, it means we're multiplying it by itself. So it's 3 minus 6i times 3 minus 6i. And I FOIL that out or multiply it vertically. I'll do the vertical multiplication again. I get negative 6i times negative 6i is positive 36i squared. I get the negative 6i times the 3, so we get negative 18i. We get the 3 times the negative 6i, which is negative 18i. And 3 times 3 gives me positive 9. So I get 9 minus 36i, and I squared is negative 1, so that becomes minus 36. Combine your like terms, negative 27 minus 36i. And lastly, number 20, 4 minus 9i times 4 plus 9i. So let's put 4 plus 9i underneath, and I get minus 81i squared. 9i times 4 gives me 36i. And 9i, or 4 times negative 9i is minus 36i. And then 4 times 4 is 16. So my 36i's cancel. I get 16 plus 81 because, again, I squared equals negative 1. Negative 81 times negative 1 is positive 81. And we get 97 as our final answer. So these next couple problems are not on your review sheet. Solve by algebra and find the zeros. So we're going to solve by algebra here. This is by algebra, or the square root property. So we're going to add 5, and we get that 3x plus 1 squared equals 25. We're going to take the square root of both sides. Don't forget that plus or minus. Every time you take the square root of both sides of an equation, we get 3x plus 1 equals plus or minus 5. Subtract 1. 3x equals negative 1 plus or minus 5. Divide by 3, and x equals negative 1 plus 5 is 4. 4 divided by 3. Negative 1 minus 5 is negative 6. Negative 6 divided by 3 is negative 2. So we do two things, negative 1 plus 5 over 3, and we do negative 1 minus 5 over 3 to get our two final answers. If we have the next problem, let's say it is 5x squared minus 31 equals 5. So we're going to solve this by adding 31 to both sides. We get 5x squared equals 36. We need to divide before we square root, so get rid of the coefficient before you square root. So x squared equals 36 over 5. Now we can take the square root of both sides. And this is one of those problems where the top I can take the square root of plus or minus 6, but the bottom I cannot. So I need to rationalize the denominator by multiplying by the square root of 5 over the square root of 5. And that gets me plus or minus 6 square root 5 over 5. And our last set of problems is find the zeros. If f of x equals, let's pick a good problem here. X squared minus 14x plus 40. So when I'm asked to find the zeros, I want to know where the equation equals 0. So I change the f of x to 0. And if I have a bx term, I can't use algebra, so that's out of the question. Our four methods are algebra, factoring, completing the square, and quadratic formula. And really in that order, we want to first, if we can solve by algebra and we get a choice, we want to do it that way because it's usually pretty quick. Solve by factoring is definitely faster than the other two methods. So see if you can factor it first. Can you think of two numbers that multiply to 40 and add to negative 14? Well, 4 and 10, that should work. X minus 10 and x minus 4 equals 0. And then x equals 10 and 4. So the factoring worked. If you can't factor, you want to think, can I complete the square? This would not be a bad problem to complete the square on because we have an even b term and a coefficient of 1. So that's going to make it easier. But if your b term is odd or your coefficient doesn't divide evenly into all your other numbers, then completing the square is probably going to be a mess. And so then lastly, you choose quadratic formula because that usually takes longer.